Well, we could probably talk about the whole interview on that, but it really was one of the stimuluses of the book. Obviously, nitrogen is the subject of a lot of books. Organic gardening is based on the idea that you're getting, natural nitrogen, the right kind of nitrogen, et cetera, et cetera. And so in this instance, we're dealing with a situation where people were using regular fertilizers, not regular fertilizers, but just normal inputs, manures, et cetera, et cetera. And one day, somebody got up in the British Society of Science and said, wait a second, we're running out of nitrogen, and challenged the world scientists to develop artificial nitrogen. And lo and behold, someone finally did in Germany. Of course, the story is well known. And this nitrogen became a artificial manure, a fertilizer. And then shortly after that, World War I, World War II, and the nitrogen was being used for munitions. And so as a result of that, the wars ended, the munitions were converted into fertilizers, and the production of nitrogen is artificially completely outpaced what the original production of nitrogen was like. So over 50% of the nitrogen in your body is artificial nitrogen. Now it's nitrogen, but it was made, using a man-made process, not using a microbe process. So it's just a fascinating, sort of outlook on, where we are in terms of gardening and farming. We used to have natural nitrogen. Now we're using artificial nitrogen. We're having a lot of problems now. And we're going back to the natural nitrogen again. So it's a nice cycle, I hope, that we're going to see. Because when you apply nitrogen in an artificial form, the plant is sort of force-fed that nitrogen, and what happens, we've discovered, is that the plants kind of shut down a lot of their systems. They say, whoa, wait a minute, I'm getting free lunch. Why am I spending all of my energy, trying to attract microbes and feed myself? I'm getting free lunch. And so they react differently in the soil, and I suppose hydroponically as well, but certainly in the soil, they react differently. So they stop attracting mycorrhizal fungi, for example, because they don't need them. They don't need to spend the energy to keep them alive. It's a symbiotic relationship. And so they cut back on the need for nitrogen fixation because they're getting free nitrogen. So they don't have to form those nodules and attract the bacteria. All of this stuff, sending signals out into the soil. It's a difficult situation. The plant has to run through, spends a lot of its photosynthetic energy producing exudates which drip out into the system to do all these things. Maybe 50% of its energy, maybe 60% of its energy. And then all of a sudden you're giving it free food. It says, whoa, I can keep that energy for myself. And I don't have to spend it. I can relax a little bit. And so you get a different situation for the plant. And then the plant becomes dependent on you. Oh, absolutely, absolutely. And particularly with the artificial. I mean, that's an obvious problem. I always like to point out that gardeners use 4 times more nitrogen than farmers. So when you think about that little spot down at the bottom of the Mississippi Delta, you can't just think that's just farmers. If you are using chemical nitrogens, they are for all intents and purposes, running into the water system. And some of it is hitting the plant, some of it's being taken in. If you're using an organic nitrogen, it's held in the soil. In particular, it's held in the bodies of the microbes and the bigger organisms that eat the microbes. So it stays there, and it's there, it's available when it's needed. Big difference, big difference. The example is the nitrogen that's created by nitrogen-fixing bacteria. So I've got 2 books out in print. One of them is called Teeming with Microbes, and it explains the soil food web. And the way the soil food web works is if I can explain a 200-page book in about 30 seconds, the plant produces these things that drip out of the roots. They're called exudates. It uses its photosynthetic energy, as I said, up to 50–60% of it, to produce these things, not the tomato, blah, blah, blah. These things drip out of the root system and attract bacteria and fungus because they need the carbon that's in these wonderful little exudates. Along come protozoa like paramecium and amoeba, and nematodes, which are these little teeny microscopic worms, and they eat the bacteria and the fungus because they too need protein and nitrogen and carbon in particular, so it's mostly carbon. They eat what they need, they poop out what they don't need, and they're doing this all right there in the root system, the rhizosphere. And lo and behold, what they poop out is in plant usable form, and the plant is feeding itself. It attracts the right kind of microbes in order to feed it what it needs. Amazing. And then you have these mycorrhizal fungi that they attract. They send a little signal out. The fungi reacts to the signal, enters into the root system, and you end up with these beautiful, but very tiny extensions to the root system that go out. They're fungi. They go out and they bring back food, and they feed the plant in return for those exudates. And they get nitrogen, which we've just talked about. They get phosphorus in particular. They get copper. They get water. They do all sorts of terrific things for the plant, and 96% of the plants have these things. Now you come along with artificial nitrogen, and the plant goes, wow, I don't need to support those guys. I don't need to do this. It changes the whole situation. So it's fascinating. So the second book, however, is what happens with the nitrogen that's produced. How does it get into the plant? And then once it gets in the plant, what does it do inside the plant? And it's here that you begin to recognize that there's really two kinds of nitrogen that plants take in, ammonia and urea. And depending on what kind of plant and where they are, they like one over the other. And so if you're a good gardener, you try to figure out which nitrogen your plant prefers. And that's all part of the system of the books. Now, I've got a third book coming out in January on the mycorrhizal fungi themselves, because they're that important. There are that many plants that have them. They are the reason we have life on Earth today, plants associated with these fungi and came on Earth. And so as a result, all of this stuff plays together, and when you disrupt the system, you find out that the fungi don't work, the nitrogen fixing don't work, the soil food web becomes disrupted, the plant maybe is getting the wrong kind of nitrogen, and all of a sudden, first of all, you're glad you read all three books because you understand what's going on, but you can see how the whole system works, and that's really, really, really important. We spend too much time on mythology as gardeners and farmers. You know, my grandfather did this, and my grandmother said do that, and you know, we made compost the way she did it. No, we need to know the science behind all this stuff. We need to get into it that way.